While modeling is fairly straightforward, texturing is more abstract in that you can't just copy the exact shape of something. Instead, you have to work on your textures until, well, they just feel right. At the end of the day, all you do is paint the correct color and make sure light reflects accurately. Quite frankly, there are two parts to a realistic render, and modeling is not one of them. Texturing and lighting are the heart and soul of a good image. The actual shape of the model doesn't really matter at all. To paint the textures, we usually use Substance Painter, which is like Photoshop, but in 3D. In this video, I will only use already existing Substance Painter materials and make some modifications to those. Normally, when we create our textures, we have to put a tad bit more effort into it, so don't be fooled by how easy it seems when I do it, because I am really underselling texturing artists here. The handle seems to be a brown leather material, so I grabbed a similar looking preset and applied it to the entire hammer. You can see in the top right that all the elements of the material exists in a folder, and instead of painting it only to the relevant parts, I flood the whole image with them, then apply a black mask to the folder itself. A black mask hides everything that it is added to, and when I paint white on the mask, the layers underneath will be revealed. It's like putting a black piece of paper on top of a painting, then cutting sections out of the black paper, revealing the painting. This way, I can change the material however I want in the future without affecting where it is applied to, and vice versa. I then did the same to the gold rings and the steel caps. This is my general workflow, as it makes things a lot more adaptable for everything. A quick Google search says Marjolnir is made of uru. Rather unsurprisingly, uru is not a standard material in Substance Painter, so I decided to go with steel and 2 layers of dirt instead. For dirt, I added a layer with darker color. More roughness then, once again used a mask. In this case, it is not a pure black and white mask, but a mix of grey shades, resulting in the pattern you see. At the corners, we seem to have the same material, except it's darker, so I copied the original one, made it a bit darker, and changed the mask to reveal the correct areas. As the embossed parts would be too complex to actually model onto the geometry, we can use a height map that will displace the geometry during render time. To add the correct pattern, we are creating an alpha brush, which works very similarly to the alpha masks we used before. Paint will only be applied where my brush is white, so I drew up the shape in Photoshop. You can now see how the alpha brush works. Once we are done with all that, we can work on the height map. As I am moving the slider in the bottom right, the geometry is extruding or intruding, and that will actually render with displaced geometry. This way, we don't have to spend endless hours modeling such fine details. Instead, we can just draw it on. All we have left now is the top part, which seems to be a darker and shinier version of the same material. So I quickly modified the uro. I did the engraving on the top the same way I did the embossing before. Paint on the text, intrude it, and done. Lastly, we add a final layer of dirt for the whole hammer. You can now see how what we painted onto the 3D object is actually translated onto the 2D plane, forming a standard image that we can export and re-import back into Manga. Let's run through the maps we've created. This is the base color map, and you can see where the leather will be, and where the gold and steel are. This next one is the metalness map. This is a luminance map, where completely white means one end of a given spectrum, and black means the opposite end. In this case, white is completely metallic, and black is not metallic at all. This is the normal map, which we won't add now, but it can create the illusion of 3D depth on a 2D surface. It is similar to the height map, but it doesn't modify the geometry. Instead, it tells the program how to reflect light from it in a way that makes it appear 3D. It is used in games, and for very fine surface details in films. This is a roughness map, also a luminance map, where white is fully rough and black is completely shiny. As this is a mix of grey, our roughness will be somewhere in between. And lastly, the height map. This is a mix of the normal map and a luminance map. Whatever is white will extrude, and whatever is black will intrude. The image is deceiving because it is 32 bits instead of 8 bits, which monitors can handle. So what appears here as black isn't real. Again, this will only happen during render time. In the viewport, it won't actually make any difference. The final step in this process is creating the shader network, connecting the files, and applying it to the model. I won't bore you with the details because it's not important now. I set up a basic HDRI light and camera because just like in real life, in CG programs, we always need these as well, and we are ready to render. And that's it. We are done. Mjolnir is now fully textured and ready for rendering. In the next video, we will shatter Mjolnir and add the lightning effects in Houdini.